This is not exactly a section in the book, but what I wanted to look at on these problems is show you how to work out a few derivative problems and just the kind of thinking we're going to do using derivatives to answer larger questions. So far, we've been keeping it kind of basic in class. I just straight up find the derivative, find the equation of a tangent line, some of the basic stuff. These are three of the more difficult problems that you're going to see. And I was just going to work a few examples and let you see how, hopefully, how to think these things out. Where you have to find the derivative, but these problems ask you to kind of go above and beyond just the derivative and use it in a way maybe we haven't used it before. So number one here, it says where does the normal line to the parabola, so we have a parabola, and they give you a point, and they want to know where does this line intersect the graph a second time. Now I have told you many times that I'm a very graph thinker, and I'm going to kind of visualize this thing by graphing it. I have the parabola y equals x minus x squared. If I factor an x out of that, I find out that the x-intercepts for this parabola are at 0 and 1. So what I'm going to do is sketch this graph real quick. Actually, it's opening down, so let me move this up. So I have an x-intercept at 0, I have an x-intercept at 1, and I have a parabola that does something like this. And that's just kind of a crude graph. You can see I missed my points, but hey, you know what? I don't care, and you can get over it. So here, watch this. I can fix it. Yeah. Oh, no, I missed again. Such a loser. Oh, whatever. Okay, so there's my parabola, and I'm about to have to sneeze. Yeah. Hey, there we go. Take that. Wake up. All right. So anyway, we have a parabola, and we're looking at the point 1, 0. So we're looking at this point, and it says the line normal. And if you don't remember what a normal line is, a normal line is perpendicular to the tangent. Perpendicular to the tangent. So if my tangent, I can kind of visualize my tangent coming down like this, the normal line is going to be perpendicular to it. So my normal line is going to come around like this, and this problem is asking when does my normal line intersect the graph a second time. So we're looking for that ordered pair right there. So I have the point of normalcy, I guess you would call it. And we are talking about a normal, which is perpendicular to a tangent. And when I think tangents, I'm thinking derivatives. So I'm going to find the derivative. And my derivative is, it's going to be just what? 1 minus 2x. And I also know that my point of tangency, or my point where the normal line hits, is at x equals 1. So if I plug in x equals 1, my derivative, and actually the way you write this is the derivative such that x equals 1, it is 1 minus 2, negative 1. Well, negative 1 is going to be the slope of the tangent because I plugged in negative 1 to my derivative. So that's my tangent slope. And I'm just kind of feeling my way through this problem. I saw a normal line, which made me think tangent, and so I'm finding the slope of my tangent. And if that's the slope of my tangent, well, going back to algebra 1, I know my normal slope, the slope of the line normal, is going to be positive 1. It's the negative reciprocal. So the slope of my normal line is positive 1, and I know my normal line goes through the point 1, 0. So what I can actually do is write the equation of my normal line. So my normal line equation, I wish they didn't call it normal, and I wish my writing was better. That is crap. Let's try that again. Normal. My normal line, whoops, forgot the I, is y minus my y coordinate of 0 equals x times x minus, my slope, which is 1, times x minus 1. And that cleans up to simply y equals x minus 1. So there's my normal line, but it didn't ask what is the equation of the normal line. It referenced the normal line, so I found the normal line, but what I'm interested in finding, again, is where my normal line hits my graph a second time. So really, all I need to do now is find the intersection of my normal line, y equals x minus 1, and the parabola, y equals x minus x squared. And if you ever want to find the intersection of two graphs, you set them equal to each other. So my intersection is going to be whenever the graph of x minus 1 is equal to the graph of x minus x squared, and we'll solve that. my x's cancel. If I subtract the x's, they cancel. So negative 1 equals negative x squared, which means 1 equals x squared, which means x is equal to plus or minus 1. Ooh, I got 2 points. Why did I get 2 points? We'll see those x's cancel. I got 2 points because they do intersect twice. One of them is at the point of tangency, so x equals 1 makes sense, right? And my other point is at negative 1, and that's where my other tangency is. So that's my x-coordinate. It says, where does the normal line intersect a second time? So I have the point 1, 0. I need to find the ordered pair that goes with negative 1. So I'll just plug in negative 1 to my parabola. Negative 1 minus negative 1 squared. And that is negative 1 minus 1 is negative 2. So there is the point where my normal line intersects my graph the second time. So I found the equation of the normal line, and then I simply needed to find the intersection of the two graphs. Good, good. How long did that take? A lot longer than I thought it would. Yeah. So basically started with the tangent, needed the negative reciprocal for the normal slope, and then we set the two equations equal. So there's one kind of a bigger problem where you're going to use derivatives to answer something a little bit off the beaten path. Let's try another one. This problem right here, actually, probably should have done this one last, because this is one problem that people really struggle with. And what I've done is I've given you the equation of a parabola, x plus x squared plus x. Now I'm going to go ahead and sketch this graph. So I have x squared plus x, so y-axis, x-axis. My x-intercepts, if you factor that, you take out an x, your x-intercepts are 0 and negative 1. So there are my x-intercepts. This is a parabola that opens up. So I'm going to come down and go back up. I don't like that. Do y'all like that? I don't really like that. I'm going to come down a little bit wider. Nah, that's stupid. Go back up. Whatever. So we have a parabola. So I sketch my parabola of x squared plus x. And notice here, I'm talking about two tangent lines that pass through the point 2, negative 3. Well, 2, negative 3 is not on my graph. I didn't give you a point on the graph. I gave you a point floating way out here somewhere, right? And I need to find the equation of the tangents that go through that point. So I'm going to have one tangent that comes kind of out that way. So I'm going to have one point of tangency out there. And then there's going to be another one that goes way up high that intersects my graph somewhere way the heck up there. Okay, so our challenge is to find the coordinates where they intersect. So I need to find these coordinates right here. I want to find the point of tangency for those tangents. Well, I don't know what the point of tangency is. It's unknown. So what I'm going to do is I'm going to call that point simply, I like to call it just something general like A. And if my x coordinate is A, my y coordinate is going to be f of A. Okay, I don't know what my coordinates are, so I'm just going to call it A and f of A for now. But since I know that f of x is x squared plus x, I could call this point A and A squared plus A. I can simply plug in my x coordinate to get my y. And it's very generic because I don't know what the point is. So I don't know why I wrote it up here. I'm going to write it down here. Give me some more room. So my x coordinate is A, and my y coordinate is A squared plus A. So there's my point of tangency. And what I've got to do is find a way to get that point. I know the x coordinate is A, because I just made that up. Got to find the y coordinate. We are dealing with tangents, so the second I see tangents, I'm thinking derivatives. So let's find the derivative. The derivative of my parabola is 2x plus 1, right? And the parabola, the derivative gives you the slope of the tangent at any point, and I need the tangent at A. So my tangent, my derivative at A is simply going to be 2A plus 1. And that is the slope of the tangent. Now that by itself doesn't help me a whole lot. The slope of the tangent doesn't help me here because it's still in terms of A. That doesn't help me get A. So what I've done right there is I've used calculus to find the slope of the tangent. I called the point of tangency A, I took the derivative, and I plugged in A. So that gave me the calculus slope. But let's not forget the fun we had in 8th or ninth grade when you took Algebra 1 and you learned how to find the slope between 2 points. So I'm going to find the algebra slope also. Forget calculus. Let's go into algebra for a second. How did you find slope in algebra? That's right. It was your y-coordinate minus the y-coordinate, which in this case is going to be a squared plus a minus this y-coordinate, negative 3, over my x-coordinate a minus my y-coordinate 2. So that cleans up to a squared plus a plus 3 all over a minus 2. Okay, so what I've done is I found the slope of the purple line of my tangent using algebra, simply changing y over changing x, and I found that same slope using calculus and derivatives. Well, if I found the slope of the same line, then my calculus slope and the algebra slope has to be the same. Those are the slopes of the same line. We just use different techniques to find them. So we're going to go into algebra again, and to solve for a, we will simply set those two equations equal to each other. We set the calculus slope to a plus 1 equal to the algebra slope, which is changing y over changing x. And now we go into solving the equation. I don't like fractions, so I'm going to multiply both sides by a minus 2. Multiply by a minus 2. And we will FOIL on the left side. I'm going to pause while I FOIL. All right, so I FOILed the left side. I canceled on the right side. And finish solving this equation. I'm going to move my a squared over, make it 2a squared minus a squared is a squared. I'll subtract the a, make it minus 4a. I'll subtract the 3, minus 5 equals 0. Good, good. And then we'll factor that. A plus 1, a minus 5 equals 0. And we get a's of negative 1 and positive 5. So I get one tangent that happens at negative 1, so it was a little bit off, but negative 1 makes sense. I will have a point of tangency around negative 1. My other one, positive 5, is like way the heck over here, but it's way up off the graph, somewhere up there. So those are the two x-coordinates of tangency, negative 1 and positive 5. Now I did say find the points of tangency, so I need to find the y-coordinate also, and that's pretty easy. We'll just plug those into my function. So negative 1 squared plus negative 1 is 0, so negative 1 is 0, and if I plug in 5 squared is 25, plus 5 is 30. So there are the points of tangency for the two tangents that pass through that point and are tangent to the graph. So find the calculus slope, derivative, plug in a, find the algebra slope, changing y, changing x, set them equal to each other. Not a terribly common problem, but happens just enough to tick you off. Right. All right, one more problem. How much time have I spent? 13 minutes. All right, one more problem, and this one's not as bad, although it seems weird because you don't like having all this vague equation stuff. I give you a parabola, just a general quadratic equation, ax squared plus bx plus c, and I give you a bunch of information, and I want you to solve for a, b, and c. I'm asking you to find the specific parabola. Well, let's look at this first sentence. The parabola has a slope of 4 at 1. Well, slope is one of those key words in calculus. The second I see the word slope, I'm thinking derivative. So I'm going to find the derivative. My derivative y prime is, and remember that a, b, and c are just constants. They're numbers, so it's like having 5x squared. So the derivative, I would bring down the 2, multiply it by the constant, times x, and minus 1 would be x to the first, plus the derivative of bx is simply going to be b, and the derivative of c is 0 because it's a constant. And my slope is 4 when I plug in 1. So y prime at 1 is going to be 2a times 1 plus b, and that needs to give me a slope of 4. And then when I plug in negative 1, I have a slope of negative 8. So y prime of negative 1 is equal to negative 2a plus b, and that would equal negative 8. Are we good? Are we good? And then the last bit of information, my parabola actually goes through the point negative 2, 6. Now that's not calculus, that's just saying when I plug in negative 2 for my x's, my y-coordinate is going to be 6. So That ordered pair gives me an equation. 6 is equal to a times negative 2 squared would be 4a. B times negative 2 is negative 2b. And c. Right? 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 So what we have here is 3 equations. I have one equation right here. I have one equation right here. And I have one equation right here. We have 3 equations, 3 variables, and we need to solve this system of equations. And I see 2 right now that are just sexy. This is not going to be too bad because I'm looking at these 2 equations right here, and I notice that if I simply add those 2 equations, I have 2a plus b equals 4, and I have negative 2a plus b equals negative 8. If you add those 2 equations, the a's go away. 2b equals 2b, or not to be, equals negative 4 divided by 2, and you get b is negative 2. So now I've solved for b, and once you get one variable, the rest of them usually pretty quickly fall back into place. So now that I know b is negative 2, I'm going to plug it in. I'll just plug it in right here, and that'll give me negative 2a plus b, which is negative 2, equals negative 8. We'll solve the equation. Negative 2a is negative 6. A is equal to positive 3. And then now that I know a and b, I can plug them in for a and b in this equation to solve for c. So 6 is equal to 4 times a, which is 3. So 4 times 3 is 12, minus 2 times negative 2 is negative 4, minus negative 4 will be plus 4, plus c, and we'll solve that. 6 equals 16 plus c. C is equal to negative 10. So I solve for my a, b, and c. And then finally, you take all 3 of those and you write them in the quadratic form up here. So y is equal to a x squared plus bx, and b was negative 2, plus c, and c was negative 10, and that would be your answer. Yeah, so we're still using the normal derivatives. We're just using them to answer larger questions. And these are 3 types of questions that you could see. And we'll see some other tricky ones also, but we'll work through those some other day. So there we go. I will see you in class tomorrow. Take care.